folks aren't aware what they're in for, we're going to have a quick chat and maybe a tiny amount of demo going over iPXE. And so I know iPXE mostly as a thing I use in the background, if not dozens of times per day, certainly dozens of times per week. Usually works properly, and then I don't think about it too much more. But today we'd like to think about it a little bit more. If we haven't received really solid intros, Michael Brown of iPXE has joined me, and so can you tell me a bit about yourself first, but then where did you get started with iPXE?
So I got started with it back in the early 2000s when it was called EtherBoot. The name iPXE didn't happen until about 2010. And from my point of view, it was as a user in the first place. So, a user with a use case that it didn't quite cover, and that got me into developing a new feature for it, which is always a great way into any open source project, to find something that almost but not quite does what you need it to do. So what I had at that point, I had a customer who wanted to do wireless diskless workstations. So it's an educational customer in a fairly rough area of the country, and they wanted them to be wireless so they could move them around easily and reconfigure the rooms, and they wanted them to be diskless specifically so that if someone stole the equipment and tried to sell it down the local pub, that the person who bought it from them would then punch them in the face because they sold them a useless computer. So I had this customer with a slightly odd requirement for wireless diskless booting, which is something that just didn't exist. So I did some searching around, found EtherBoot, which was, okay, here's an open source project that does diskless boot. Doesn't do wireless, but okay, right, let's buy a wireless card. How hard can it be to write a driver, having never written one before? And that was fun. And I really enjoyed that process of getting into doing proper low-level hardware code. And that was also, I think, my experience of learning C properly at that point. And that was my first contribution to the project. That's how I got into doing EtherBoot. And then that sort of followed on from there. And once I got out of the business that I was in the first place, which was providing computers to educational environments, the whole network booting stuff really took off. And I found actually there's quite a few people who are interested in this and who want to develop it further. And this was all happening sort of in parallel with Intel having their PXE initiative. So Intel had brought along this standard for network boot, which is very basic and very limited in what it can do compared to what EtherBoot could already do at the time. But it was an industry standard promoted by one of the biggest manufacturers. And so people start thinking that's how network booting should work. And you get stuff that's built around that, things like PXE Linux that expects to have a PXE stack underneath. So there's a ton of documentation around the web at this time that says EtherBoot is not PXE. It's a different way of doing network booting. And here's all the complicated stuff you're going to have to do to get it to work. And a guy called Marty Connor, who I don't know if he's listening or not, he may be on here, he had a great vision, which was that essentially EtherBoot needs to support PXE. Because it's all well and good doing fantastic, exciting stuff, but if you don't support the basic industry standard, then it's just going to die because people are going to not use it, and you're only going to get specialists interested in it. So he very generously personally funded the development of the PXE component of EtherBoot, which I did the implementation of. And that was sometime back in the early 2000s. It was version 5, EtherBoot 5.3. I can't remember exactly what year it was. And then we decided to rename it to gPXE because of all the documentation on the web that says EtherBoot does not do PXE. You will have a hard life if you try and use EtherBoot. And let's get away from that. So did the rename. So EtherBoot to gPXE was essentially just a rename to make it clear that it now does PXE. And the G is there just to say it's open source, it's GPL. It was a nice, easy way to say that. And that developed nicely, added features and so on over the years. We talk about the development model later, but we got to this point in 2010 where I'm just going to phrase it as creative differences with Marty. I wouldn't say either of us was right or wrong, but we parted ways at that point. He had the domain name etherboot.org and gpxe.org, so in order to take the code and keep developing it myself, I had to find another name. And I am really, really fussy about how the code looks on screen. So I needed a name that was exactly the same length so I could just do a search and replace across the code base and not have to worry about lines going over 80 characters, which would have seriously perturbed me. So here's the case essentially of looking for another letter that I can stick before PXE. that I can then do a search and replace on. And I was available, and we had iXE as a feature, and it's around the same time that iPhones are fashionable. And it's like, okay, that works as a name. You can think of it as Internet Pixie, but there's an FAQ on the website that says, what does the I stand for? And it doesn't. It's just a name. So.
And has a 4-letter domain name available, which are
that was also a big restraint.
In very short.
Yeah, I only managed to get the .org at that point, and then 11 years later, the .net finally became available, and I got that. The .com still eludes me.
So. Curious, who's holding on to that and what they're using it for?
I have no idea. Actually, I haven't tried browsing to it for ages. Someone can look and tell us in the chat.
So what sort of places have you seen iPXE being used? You're probably the best to say as closest to the project.
So, yeah, I mean, it would be nice to say that I knew where it gets used, but as you mentioned in your intro, it's something which just works most of the time and you tend not to touch it. And I think that's how most people interact with it. So I generally only get to find out about it if it doesn't work for somebody, or if they want a specific extra feature. So I will occasionally find out that extremely large organizations, I'm not going to say names because I've got no idea how much of this is under NDA, but let's just say off the scale of Google, but definitely not Google, are using this. And it's like, okay, but I never knew they were doing it until this one moment when one of my customers happens to mention it in passing that, oh yeah, they supply that company.
What have been some of those
random emails?
What have been some of those asks at large organizations?
So the sort of developments that I get usually split down into two things. It's either hardware support, so typically someone who makes a network card gets in touch to say, actually, we'd quite like it to work on our hardware because we have people we're trying to sell to who want to use it because their deployment environment's already built around iPXE. Or it's people who want specific features developed. So, for example, I've had people who want to be able to figure out the CPU topology of the system before booting the kernel so they can construct a kernel command line to tell it to isolate some CPUs into a dedicated pool that doesn't get used by the normal scheduler. So we added capability to iPXE to essentially rip out the entire ACP table and post it off to an HTTP server that can then go through and say, okay, so here's your command line, stick those 2 Linux numbered CPUs into their own little pool, which happen to be close to your high-speed network card, and you can guess the customer type from that. So esoteric use cases, the sort of thing that aren't generally useful, but I always try to find a way that means that it can become a feature that is generally applicable. So rather than developing a feature for how can we identify CPU isolation, it was more a case of, okay, well, HTTP post is generally useful to have. Let's get the ability to build any HTTP post query with any information that iPXE is capable of ripping out through a settings mechanism. And then separate and complementary to that, okay, well, let's take the ACP table as part of the stuff that iPXE should be able to access. So yeah, we just give iPXE the ability to do that and make it a general feature because then other people can use it. And for this sort of code size, the compiled binary size is such a massive premium that you have to do all the features in that sort of general way. If you start addressing every single custom feature request as we implement that and not think about the wider vision, then yeah, you run out of code. The binary size ideally would go under 64K. I tend not to care about that so much nowadays, but it's definitely well under 96K kilobytes for the compiled binary, including the C library, the device drivers, the TCP stack, the shell, the menuing system. All of that is fitting in a pretty small amount of space.
Nice. I suppose it's a good time to mention friends in the chat. If you have questions, drop them in the Q&A, and we'd be happy to address them here. Yeah, I saw iPXE scroll by this morning, and then enjoyed this morning's EVE-OS demo. Part of the tiny portion of it highlighting the capability that has been with Equinix Metal, I suppose, since we're the artist formerly known as Packet, since the 2017 or so was the ability to iPXE boot your own OS onto or your own arbitrary OS onto bare metal via either the console, or you can also do that over API, making it easier and repeatable. What work did you do on iPXE to either allow or ease the installation of EVE-OS?
So I picked one feature to demo for this, which I'm going to try screen sharing, and we'll see if it works.
Love demos.
Okay, please tell me, do you now see a console?
I now see a console.
Excellent. Okay, so when I say live demo, this is properly live demo. This is actually building the system and trying it. So with the CPU spinning at 100%, we'll see if it does anything. So here is iPXE coming up on a VM and just doing a basic Linux kernel boot, which we'll just happily run through. And the thing I want to show is, let's get to a shell. Okay, so the script that it booted from is here. So this is the script that the server handed back to it. And you can see you've got a kernel command line coming up, a basic init ramfs image, and then the interesting bit that we're going to talk about is the injection of all these kernel modules. So the architecture here is that you've got an init ramfs, which has only user space code in there and no kernel version dependencies. And then you have the ability to add kernel modules and have them show up at certain places within the file system. And if we switch back over here and look in the lib modules directory, you can see that these files have indeed appeared. So the reason this is handy is it means I can have an init ramfs that's just there, and that is my thing that I want to boot. But if I need to change kernel, obviously don't want to have to rebuild that. I don't have to. And this mechanism allows me to say, well, I can pick up individual files, drop them in there. I could even, if I wanted to, have this be dynamic and have iPXE do things like enumerate the PCI bus, send that off as part of the HTTP request, and get back a list of specifically the modules that it should be loading. So this mechanism has quite a lot of applicability and is nice in general. But until very recently, it only works on legacy BIOS. And that is not particularly useful for EVE, because they have to be able to run on ARM, which has no concept of legacy BIOS, and so we're talking UEFI only. The way that this works on BIOS is that iPXE essentially has the concept of a CPIO archive, and it will happily say, okay, well, there is a single thing. I'm just going to say, there's a binary blob. It already has to be a CPIO archive. And then these lines here, that is saying, right, first download that file from the web server, and then inject it by adding the CPIO headers to give it that file name. And then it just concatenates these together, and Linux happily sees it and builds a file system out of it. And we want to do that on UEFI as well. UEFI has a very different way of booting. So whereas on legacy BIOS, we just say, here is a huge blob, and this is your init ramfs image. Let's bring this one up. On UEFI, we have a slightly different approach. So here is another virtual machine booting. Give an IP address, and I'm just going to download a few files from the local machine. Should exist. Did I type that wrong? Yep, there's no boot in there. So that's on file. Let's grab another one. And we should see that we've got some downloaded files. Yep. And then lastly, I'm going to drop into the UEFI shell. Okay, so here is the UEFI shell. And what this is going to show me is that iPXE has downloaded all these files already and exposed them through a virtual file system to any UEFI application. UEFI application here is the UEFI shell, just so that I can interact and show the listing, but it could also be the kernel. Now the kernel, if I start it up, is capable of being given a command line to say, please load this file from the virtual file system. And I can do that multiple times, so I could give it some extra things, whatever. But it gets very cumbersome, not least because all of these files have to be pre-wrapped in CPIO headers. So whereas the legacy BIOS, you've got this really nice feature that a completely unmodified file just taken from your compiled driver tree can be dropped in and injected to appear at a certain path within the file system. You just couldn't do that on UEFI. And yeah, they wanted feature parity with that, which is what we did. So I added this feature called the Magic initRD, which essentially just ported the whole, we know how to build up a CPIO archive code and generalize that and made it available under a single virtual file within the virtual file system that you just saw, and then the kernel can pick it up. And if I let the kernel boot without fiddling with it, come back up. So we just tell it to boot automatically. That should, even though this is a UEFI system, have picked up the same set of files, and they should show up under lib modules. Yep, and the whole thing works. So yeah, just basically, that was a nice example of a small feature. It was only about a day, 2 days work altogether, but Sadida needed it. in terms of the commercial model, it's, well, okay, this is really not worth them learning how to do the patching the iPXE code to deal with this. It's a very specialized coding environment. It makes much more sense for them to say, come to me. Yeah, I will tell you it will cost about 2 days' work to build this. And yeah, there you go, have it within a week. And that's kind of the commercial model I like to go with.
Yeah, it seems more reasonable than the SaaS model, I guess. Whether that's like a penny per boot, or the text there was very much reminiscent of the arcades that I would go to when younger. And like, iPXE 1.0.256. Please insert coin to continue.
Sweet.
But yeah,
yeah.
It features where you go, and you're like, and you're where you and you're the best place to insert that coin. That's excellent. Also, looks like there's a question from Shan. Hello, Shan. Is it possible to connect a set of edge devices on a LAN and do a net boot using iPXE on these devices, sort of like hot plugging edges?
I'm not sure I understand the question, but you can definitely hook a whole load of devices onto a network and then net boot them. But could we get Shannon? Can you clarify the question? I don't think we can ask direct audio, can we? We have to do this by text. But that does remind me of something I'd like to give a shout out to in terms of feature development. So, a company called 2 Point Software and a guy, Andreas, who I think is with us in this chat. One of the things which they sponsored the development of was the ability to do peer-to-peer booting with iPXE using Microsoft's peer-disk and branch cache. So they do extremely cool things where you have the ability to boot and rebuild system images on remote site networks, or maybe you're on a satellite link because you're somebody like the Red Cross, you've just gone into a different country, you've assumed your machines are compromised as they cross the border, and you have to rebuild everything over an extremely high latency, low bandwidth connection. And the way they do this is you do one first, and then the others will pick up from there. So yeah, iPXE now has the ability to say, right, I'm going to do multicast queries and see, does anybody else have this block of this file, and grab it. And that was a fun feature to do, and exposed a lot of bugs in the networking stack in iPXE, because suddenly we actually have to deal with 32 concurrent connections, whereas previously it was just one. And you get away with a lot when you're only dealing with one connection. So yeah, the idea of a set of edge devices on a network just reminded me of that.
Yeah, I think if your iPXE server is ready to, that sounds very similar to what's going on at Equinix Metal, both what the entire business is built around, but also then a project that we use to provision our bare metal that's been now donated to the CNCF, Tinkerbell. It's tinkerbell.org if you're interested in further, but a portion of that boots is the iPXE server. And yes, when a machine that's set to Pixie boot is connected to one of those servers, then yeah, it brings over whatever instructions you've intended to, whenever it's either the once or every time it's power cycled.
Yeah, I'm always pleased to see the sort of flexible things that people manage to build around iPXE. It's fun to. I've tried very hard to make the scripting language not become a general purpose programming language, and push the idea that if you want to do anything complicated, do it server side. And the scripting language is only there to let you pull whatever information you can only get client side, and then to understand what the server says back to it. But yeah, people do all sorts of really creative things with scripting, like the customer I mentioned earlier, figuring out CPU topology, like you guys with your deployment scripts. And yeah, system administrators love writing scripts. So people like customizing their environments. And that makes me happy.
Sure enough. Yeah, I was going to ask what other interesting scripting uses you'd seen.
So I know that, say, VMware Auto Deploy is built around iPXE. I don't know precisely what their script logic does, but it certainly does some weird stuff. And yeah, we've got. So we had one feature, a guy called Christian Nielsen, who I think is also on the chat, has a site called b800.org. And what you can do there is, if your system fails to boot for whatever reason, you can have iPXE pick up the screen content and HTTP post that off to a server, so that you can then view your bug report remotely, which is
that's cool.
Kind of fun. Yeah.
Yeah, we've do a I think serial over SSH to keep an eye on machines that you don't have immediate access to. But when talking about either edge or data centers that you're away from, it's always interesting to see like, what's the trick to deal with machines that
if I don't have proper out of band access, then give me some way to get in.
Yeah, have loved the home lab movement where you can bang a fist or pull a plug out of a wall. But the more access that you get to either via API or any manner of trickery, the nicer things are.
I had a good challenge with that when we first got iPXE to boot on EC2 virtual machines. So you can, there are now AMIs that are published, and it's really easy because you just build them whenever I feel like it, and you just go and click on it and start it. But getting that working in the first place was a challenge because unlike a normal Zen virtual machine, the EC2 ones don't give you the emulated Realtek network card. So you have to have a native Zen network driver, and it has to be able to hand over cleanly to the operating system when it starts up. And the Zen that they use in EC2 is ever so slightly customized. And therefore, even though I could get it working on my local one, it's like, it's just, it's not coming up. And at this point, when we did the development for that, there's no get me screenshot of this machine. That just wasn't there as a feature. Serial was also incredibly unreliable. The serial console on AWS, I think, you can get output from it, maybe 2 minutes, maybe 3 minutes after you've terminated the machine, and with a 50% probability of 0 input. So okay, this is hard. This is a really hard debug environment. So what we actually put in was a console mechanism that just writes to a partition on the disk. So if you've got a partition label, this one's like, okay, this is my log partition. I will just happily trash whatever's on there, which means that my debug cycle is trying to bring it up, attach the disk to another machine, look to see what was in that partition. Okay, now I can see what went wrong. But debugging when you have to create your own channel is always fun.
I just wanted to jump in here and ask follow-up to Sean's question. I happen to know he's a researcher in Germany at Viva University, and he said a follow-up. He said, I forgot to add EVE to the previous question. I have installed EVE. They have a robotics lab with EVE installed on a whole bunch of Raspberry Pis, and then he asks, EVE is already installed as an image on the host. How do you handle security certs for devices if needed in iPXE?
Okay, so we're talking about certificates that identify the client device.
I would imagine, so that you want to be able to identify.
So just because I'm not entirely sure which certs we're talking about. So iPXE does have an HTTPS client in there, so it can understand things like X509 certificates and OCSP. Okay. So you can validate the server side that way. It does also have the ability to use a client certificate, but obviously you need some way of getting the client secret key. Fundamentally, at the moment, that means you need somewhere to store it on the device that iPXE is able to access. And that's going to be very device specific, because there are a lot of places you could store a key on any odd device, which are not actually secret, because once the OS comes up, any user space code could read it, depending on where you put the key. So that there isn't a general answer to that question, unfortunately.
Okay, we can do some more follow-up.
Yeah, it's the sort of thing where if someone comes to me and says, I have this requirement, I really need to make my booting secure. Yeah. That's exactly the kind of development that's fun.
That's two good takeaways here. If you have any requests for iPXE, Michael Brown's your guy. And if you want to learn more about Equinix Metal, Jeremy's here for you. I just want to thank you guys. That was an awesome description of how everything works. It's kind of amazing what complexity goes on behind the scenes that makes life simple for people like me on the user side. That's really great. So thank you guys for joining us this morning.